Fisher model with homogeneous consumers. Whenever the traders have homogeneous utility functions, the equilibrium conditions for Fisher model can be rewritten as the solution to the following convex program, Eisenberg's program, on non-negative variables xij. Maximize the summations of ei times log of ui of xi summing for all I, subject to the summations of xij summing for all I less than equals to qj for each j. Recall that ui is the ith trader's utility function, ei is the ith trader's endowment of money, and qj is the amount of the jth good. Notice that the program does not have variables corresponding to prices. The optimal solution to this program yields allocations for each trader that at prices given by the Lagrangian dual variables corresponding to the optimal solution are exactly the individual demands of the traders. We present a proof of this result for the case where the utility functions are differentiable. Let x bar be an optimal solution to Eisenberg's program. Observe that ui of xi bar greater than 0 for each I, the Karush-Cohen-Tucker necessary optimality theorem, Mangasarian 1969, chapter 7.7, says that there exists pi j greater than or equals to 0 for each good j, and lambda ij greater than or equals to 0 for each trader I and a good j, such that pi j times the summations of xij summing for oi minus qj equals to 0 for each good j, and lambda ij times xij equals to 0 for each ij, and ei over ui of xi bar multiplied by the term delta of ui of xi bar delta xij equals to pi j minus lambda ij for each ij. For trader I, let us multiply the jth equality in 6.4 by xij bar and add the resulting equalities. We obtain ei over ui of xi bar times the summation of xij bar summing for all j times delta ui of xij over delta xij equals to the summations of pi j minus lambda ij times xij bar summing for all j. Using 6.3 and Euler's identity, ui of xi equals to the summations of xij times delta ui over delta xij summing for all j for the homogeneous ui. This equality becomes ei equals to the summations of pi j times xij bar summing for all j. At the price vector pi, the bundle xi bar thus exhausts the budget of trader I. Let yi in r plus to the n be any bundle such that pi times yi is less than or equals to ei. We proceed along the lines of the Karush-Cohen-Tucker sufficient optimality theorem, Mangasarian 1969, chapter 7.2, to show that ui of xi bar is greater than or equals to ui of yi. Using the concavity of ui of yi minus ui of xi bar is less than or equals to delta of ui of xi bar times yi minus xi bar, which is equals to ui of xi bar over ei times the summations of the term pi j minus lambda ij times yij minus xij bar summing for all j, which is equals to ui of xi bar over ei times the term the summations of pi j yij minus lambda ij yij minus ei summing for all j, which is less than equals to, if we keep the first term, ui of xi bar over ei times the summations of pi j yij minus ei summing for all j, which is less than or equals to 0. We have shown that xi bar is a demand of trader I at price pi. Turning now to market clearance, observe that 6.2 implies that the summations of xij bar summing for oi equals to qj for any good j such that pi j is greater than 0. For each good j such that pi j equals to 0, feasibility tells us that the summations of xij bar summing for oi is less than or equals to qj. Let us allocate the excess of any such good to trader 1, slightly abusing notation. Let x1 bar still denote the first trader's allocation. The bundle x1 bar continues to be a demand of trader 1 at price pi, since the newly allocated goods have price 0, and adding positive quantities of a certain good cannot decrease ui. We have now satisfied all the requirements of an equilibrium.